Well, back in 1997, the SETI Institute decided to hold a series of workshops to figure out what to do for the next 20 years in SETI.
And the results of the workshop were published in a study called SETI 2020. And one chapter of that workshop recommended that the Institute pursue funds to develop a new type of telescope, an array of a very large number of relatively small dishes.
So a few years into the project, we erected 3 antennas on the Hat Creek site where the ATA is. And it was a really exciting time.
I'm excited about doing large surveys and finding objects which may not have been discovered yet. With the sensitivity that we can muster with the full ATA and the very large field of view, I think we have very good chances of finding something new with this telescope.
Use these small dishes. They have a very wide field of view, so we see lots of sky all at once, and we're looking for new phenomena, so that's ideal. We want to cover a lot of area on the sky. In the fly's eye mode, we point them all in different directions. We see 200 square degrees at any given moment.
An ATA telescope is probably one of the simpler telescopes, the simplest designs on the planet. The simplicity partly derives from the fact that we have to replicate these. Our aim is for 350 such antennas.
The thing about the Allen Telescope Array is speed. It enhances the speed with which we at the SETI Institute can explore stars and targets throughout the galaxy looking for signals. It enhances the speed with which our radio astronomy colleagues can survey the sky. It's all about speed. The Allen Telescope Array is the first truly Moore's Law facility. So we gather more information at the telescope, at each of the individual telescopes, than we can possibly process today. And we have chosen to bring that information to a signal processing building as an analog signal on optical fiber. So we don't digitize it out at the telescope. So that means we bring all the information the telescope is possible of collecting to a processing lab, and inside, then we decide to digitize it, and we use equipment that we can afford today, knowing full well that the equipment will get cheaper and wider band in the future.
At the Allen Telescope Array, we will be able to conduct SETI observations almost 24 hours a day, 7 days a week. Because of the unique nature of the telescope, we can do commensal observing. The telescope is designed to do many things at once. We can be looking at a radio galaxy and making an image of that galaxy. And it's a very distant galaxy, but along that direction, there are stars in our own galaxy that we have pre-selected to be like the sun. And whenever someone is making an image of that galaxy, we will look at those stars in the foreground and examine them for signals.
It's just wonderful and easy to do. The first images, we popped out total hydrogen images that showed pretty much the whole structure in just a few hours of observing initially. Pretty much the image that the ATA has become. It's a wonderful hydrogen machine, very good for continuum imaging, has a very wide field of view which allows this kind of imaging in a single shot, and says a lot about the quality of the images the ATA is able to produce.
And we can bring new pieces of digital equipment in, plug them in, and do a completely different kind of experiment. When we did the fly's eye experiment, we with a group of students, we assembled together in the lab a new piece of hardware. It took about 6 weeks to do that, and we ran up to the telescope and we plugged it in, and we used the telescope in a way that nobody had planned on using it. And I think there's a lot of opportunity for continued kind of work along those lines.